Okay, now let us move to matrix determinant, properties of determinants, and then running application activity. Now, let us have this. This is the application activity. Application activity. Now we consider application activity instead of running activity. It means that once everything is understood over here, so now from here we can now apply these properties that we have learned from learning activity. Okay, all right. Now let us have let us have learning application activity. Application activity. So 1, 2, 3. Okay, and here I can copy this from this syllabus here, from this booklet. Okay, so we have 2 questions. Question number 1: check if the following statements are true or false. True or false. So we have to check if what follows is true or false. You have a case, probably some number times this determinant d if it is equal to k times a, k times c, k times b, k times d. Determinant of this 2 by 2 matrix. So b, check whether, or let me choose another marker pen here. So if k times matrix A, C, B, D, if it is equal to KA, KC, KB, KD. Okay. So question number 2. Question number 2 actually. We have apply indicated transformations. Apply indicated transformations to evaluate this 3 by 3 determinant. 3 by 3 matrix determinant 1, 1, 1, 1, 2, 1, 1, 1, 2. This determinant. So by using this transformation, row 2 is replaced by row 2 minus row 1, and row 3 is replaced by row 3 minus row 1. Okay. B is write down the value of the determinant this determinant actually. Okay, so all right, now let us move to so these are exercise that are in this application activity 1 and 2 only, each of which has two sub-questions, A and B, each time. All right. So now here, if you are watching this video again, you can pause it, try to figure out what will be answers for this question. So for this activity, now let us look at the answers. Answer to this application activity. Okay, so number one. So is it a true or false? Okay, so this is false. It is false. It is false. A is false. So of course B is true. B is true. Okay. So okay, why? Because this is scalar multiplication, and scalar multiplication we have to multiply to each coefficient. But here, for determinant, this is not okay. What we should have is, in this case, k times a determinant of a, c, b, d. So is different from k A, KC, KB, KD. Okay. So why? Because this determinant KA, KC, KB, KD, because of linearity of bilinearity property of determinant, so it is linear in each row as well as in each column. So let us consider the first row. So k is a multiple of the first row. So I can factor it out and get determinant AC, KB, KD. Okay, now again by using the same property, the second row is a multiple multiple of BD row. So I can factor this second K out and I get K determinant AC BD. So all in all, so we have K square AC BD. If we had this is a 2 by 2 matrix, if you had the 3 by 3 matrix and you have a constant multiple at a scalar multiple at each coefficient, we should have it will be like k power 3. So k order of the matrix, because you can factor out any times. Here we factor out k 2 times because this is a matrix of order 2. If it were a matrix of order of order 3 and each coefficient you have the same common factor, we factor out n times, 3 times if it is a 3 by 3 matrix. Reason why in that case, so it means, in other words, if you have suppose k times a, b, c, d, e, f, g, h, I, and you have k each time, k here, k here, k here, k here, k here. So for the first row, we factor out. For the second row, we factor out k twice, k power 2. We factor out for the third row, we get k power 3 times the same determinant a, b, c, d, e, f, g, h, I determinant in that case. So, and so on and so forth. So depending on the order of the matrix. Okay, so this was not the question. It is just information. We know it from the binarity of determinant. Okay, so now let us move to question. So we said we have answered A and B. First question is answered, is okay. So now we can move to So as a conclusion, so this k squared times this matrix is different. So we said that the two matrices, the two determinants here are obviously they are different. Okay, now moving on to question 2. We apply indicated transformation to evaluate this determinant. Okay, so let us make those transformation. So we use which elementary matrix? We use the matrix of type 3, and this matrix is identity matrix of order 3, 1 0 0 0 1 0 0 0 1 minus minus E3. E3 is like 0 0 1 column, and E1 1 0 0 1 0 0. This is like 1 0 0 1 0 1 0 1 0 0 1 0 0 0 1 0 0 0 1 minus now. So the last row is 1. Others after matrix multiplication of this. So you get this matrix, then you get the difference is going to be equal to 1 0 0 0 1 0, and this is negative 1 0 1. Okay, so we know that this kind of matrix, its determinant is 1. You get a matrix in which determinant is not changed. It means that if I had to evaluate this determinant of this matrix, so I had to multiply, I get the determinant where of the matrix in which I multiply this matrix 0 1 0, negative 1 0 1, and then multiply by given matrix. So the question 1 is not about the right, make this transformation. Okay, this is it. Matrix. Question 1 is just to make it. Probably it was a mistake. Not you cannot make this row for determinant. You make this transformation for the matrix which is right. So the matrix is 1 1 1 1 1 2 1, and then 1 1 2. Okay, we make this transformation. First this transformation is done. The second one is also this type. Okay, first of all, let us see what we have to obtain. So first row, no change. Second row, no change. Third row, it becomes 0 here. This transformation, and this one also is 0. And then we have 1. So after the first transformation, second, because we have this matrix for transformation, second transformation, we are going to have again elementary matrix of type 3. So again, what matrix we have? We will have identity matrix minus now. That one was let us see. No, that is not correct. This one, this transformation is for sorry. This transformation was according to this matrix. This transformation is obtained by applying this transformation, and then what you can get here is we can do this. This transformation will give now. That was a mistake. So times now row matrix 1 0 0. Okay. So now what we have is this 100 010 010 so minus now 000 100 000. Okay, that is this first transformation. This is second transformation. This is 1 1 0 0. Now this is negative 1 0, then 0 0 1. No, one here, one here. Because the determinant must be one in order not to change, the determinant. Okay, so this is the transformation. Okay, depending depending on the transformation of matrix. Okay, this won't the order won't change anything because every time every time we won't have a determinant properties or determinant of a product of a matrix is equal to product of matrices. So in this case, what we are going to get, let us apply this one to this matrix. We will have okay, let me use another color. So in this case we're going to have 1 0 0 negative 1 1 0 0 0 1. We apply it to 1 1 1 1 2 1 0 0 1, and I'm going to get first row no change, second row we have it is going to change obviously, being here 0, being here 1. So this 2 minus 1 is 1. So 1 minus 1 is 0, and the last one won't change. So which means that after these two transformations applied successfully on these two matrices, so we can now answer some question. That was some question A. Now it answers some question B. After applying this successfully, these two transformation, we have determinant will be 1 0 1 negative 1 so 1 1 1. So finally, after those two transformation, 0 1 0 0 0 1. So the determinant, as it is a triangular matrix, I get product of diagonal element. So this means this determinant is equal to 1. And this matrix, this determinant is the same as for the original one. So we can verify it by using expansion of coefficients here, and you are obviously going to get 1. And this is done by applying the second and then applying the first, and this can be obtained similarly by applying the second and the first to the matrix and then applying the second to the matrix. Likewise, by applying the first, this one second, and applying the second, this first one, you will get the same determinant, and it's going to be 1. Okay. Let us check if we are not sure. We can check by using cofactor expansion. Let us use cofactor expansion to check if really the determinant is going to be 1. Okay, here we have 1 1 1 1 2 1. We are talking about finding this determinant 1 1 2. So expansion, let us make expand according to the first column. So we will have 1 times determinant 2 1 1 2 minus determinant 1 2 plus determinant, because there are ones, there are one here and there is another one here, so we have 1 1 2 1. So this matrix are 2 2 times 2 minus 1, it is 4 minus 1 is 3, minus 2 minus 1 is 2, 2 times 1, 2 minus 1 is 1, sorry, 2 minus 1, 1 minus 3, 1 minus 2 is negative 1. So so what we have finally is 3 minus 2, which is going to be 1. So we checked, and this is true according to what we have. Okay, now we have come to the end of this video by knowing that this determinant, which is equal to 1, is equal to determinant of the what we are asked. So for B, determinant of 1 1 1 1 2 1 1 1 2, so it must is equal to 1 according to these transformations. Okay, I think we have come to the end of this video. So till the next video, stay safe. Thank you.